Good morning, dear student. In previous lecture we studied PN junction. Now we have to study one more important concept, PN junction diode. What is PN junction diode? PN junction diode is a device which has two electrodes and which allow to flow the current only in one direction when it is forward bias. Symbol of PN junction diode. A PN junction, when provided with metallic connectors on each side, is called a junction diode or simply a diode. See one more picture which represents symbol of PN junction diode. Students, now we have to study a flow of a current in PN junction diode in details. To study a current flowing through the diode, we must have to do biasing of PN junction diode. Biasing means we have to provide external voltage across the terminal of PN junction diode. There are two types of a biasing of PN junction diode. First is forward biasing and second one is reverse biasing. See in this picture carefully. For forward biasing of a diode, P terminal is connected to the positive terminal of a battery and N terminal of a diode is connected to negative terminal of a battery. Similarly, for reverse biasing, P terminal is connected to the negative terminal of a battery and N terminal is connected to the positive terminal of a battery. Let's start with forward bias characteristic of a PN junction diode, also called as IV characteristic of a PN junction diode. For forward biasing, P region of a diode is connected to positive terminal of a battery and N region is connected to negative terminal of a battery. To study forward bias characteristic or IV characteristic of a diode, we have to draw a graph between current and voltage. Plot a graph of current versus voltage. Take a voltage on x-axis in volt and current response on y-axis in milliampere as shown in the figure. Listen carefully. This figure shows IV characteristic of forward bias PN junction diode. Initially, the current through the diode is very low and then there is a sudden increase in the current. The point at which current rises sharply as shown in the figure, this point is known as knee point. The corresponding voltage is known as knee voltage. It is 0.3 for germanium and 0.7 volt for silicon. What is knee voltage? In forward bias mode, the voltage for which the current in PN junction diode rises sharply, which is called as a knee voltage. Student, think about that. What is the cause of larger current flowing through the PN junction diode when it is forward bias? In case of a forward bias, the width of depletion region. I repeat once again, in the case of a forward bias, width of depletion region decreases and PN junction offer a low resistance to flow a high current. Above this knee point, a diode can conduct a very large current. Therefore, to limit this current, resistors are used in series with the diode. This is all about the forward bias characteristic. Now we have to study the reverse bias characteristic of a PN junction diode. To study reverse bias characteristic of a PN junction diode, we have to connect the battery. Positive terminal of a battery is connected to the N region and negative terminal of a battery is connected to the P region. This graph shows reverse bias characteristic or IV characteristic of a reverse bias PN junction diode. In case of a reverse bias, the width of depletion region. I repeat once again, in case of a reverse bias, the width of depletion region increases and PN junction behave as a high resistance. Students, listen carefully. In forward bias PN junction diode, the width of the depletion region decreases, but in reverse bias this width is increases. Therefore, practically no current flowing through the diode when it is reverse bias. This graph shows initially a small leakage current flow through the diode which is of the order of microampere. When applied reverse voltage increases sufficiently large value due to the overheating of a PN junction, suddenly a current flowing through the junction increases. This is due to a covalent bond breaks and large number of carriers are available for conduction. At this stage, diode no longer behave like a diode, and this effect is called as a avalanche breakdown. Student, after study of both of the characteristic of a diode, we can conclude that diode conduct when it is forward bias and diode will not conduct when it is reverse bias.